A warm welcome to Bangalore Mathematical Institute. So this problem appeared in IIT JAM 2021 mathematics paper organized by Indian Institute of Science, Bangalore. The problem is on single variable calculus. It's a very good problem. So let's see how to solve this. So it's given that the polynomial x bar 2021 plus x bar 2020 plus x bar 2019 so on and so forth plus x minus 1 is equal to 0. Then which of the following options are true? Exactly one real root is negative, all real roots are positive, exactly one real root is positive, no real root is positive. Okay, so what we can do here is, let's check whether the numbers 0, minus 1, 0 and 1 are the roots of the given equation. So we have, we'll call the polynomial as f of x equal to 0. So my f of x is nothing but x bar 2021 plus x bar 2020 plus so on x square plus x minus 1 equal to 0, right? So when you substitute 0, what we'll get? F of 0, all the initial terms will be 0, the last term will be minus 1, so f of 0 is minus 1. When you substitute 1, each of these terms is 1, 1, how many ones? 20, 21 ones, but minus 1 is subtracted, so answer is 20, 20. And if you substitute minus 1, what will happen is the signs will alternate. So this is minus 1, this is 1, so on, and finally this is 1. But from this term 2021 to 2021 to x square, there are 20 terms, right? In those 20 terms, there are 1010 positive ones, 1010 negative ones, so all gets cancelled. So what remains is only this particular two terms. But since x is minus 1, this is minus 1 and minus 1 is subtracted, so it's minus 2. So f of minus 1 is minus 2. So if you can observe here, f of 0, f of 1, f of minus 1 are not giving zeros. So that means minus 1, 0, 1 are not the roots of this equation. So why we need this information? What is the use of this information? Because when these three are not the roots, then if at all there are any real roots, they should be in one of these or at least one of these intervals. So what are those intervals? Negative infinity to negative 1 union, negative 1 to 0 union, 0 to 1 union, 1 to infinity. So these are the intervals. Okay, so let's take 0 to 1 case. We have seen that f of 0 is negative 1, which is negative, and we have seen that f of 1 is positive 20, which is a positive number. By intermediate value theorem, IVT is a very powerful theorem in calculus. When f of a into f of b is negative and the function is continuous, okay, the function is continuous in the interval say a to b, then there exists at least a c belonging to the interval a to b such that f of c is equal to 0, that is c is the root of the equation. So provided the function is continuous, and since our f of x is a polynomial in this particular problem, every polynomial is a continuous function, so we can apply IVT. So if you can see here, at 0 the function value is negative, at 1 the function value is positive, so that means there exists some root between 0 and for the polynomial f of x is 0. So I can conclude that implies f of x equal to 0 has minimum one real root. In which interval? 0 to 1, open 0 to open 1. So IVT, what is the main drawback is, it is giving you minimum number of roots. It won't give you the exact number of roots. Okay, it neither gives you the maximum number of roots also. But there is one technique where you can find maximum number of positive roots. That is called as Descartes rule of signs. So what is this Descartes rule of signs says is, when you count the number of changes in sign of the polynomial, so number of changes in signs of coefficients, of the polynomial equation f of x is equal to 0. So if you go back to our f of x is equal to 0, if you see here, all are positive signs from here. There is one change in sign from plus to minus only in the last two terms. Before that, everything is positive. So that means number of changes in signs of f of x equal to 0 is how many? Only 1. And by Descartes' rule of signs, when the number of changes of f of x equal to 0 is 1, there is maximum one positive real root. This is the Descartes' rule of signs, maximum positive real root. Now club this information obtained by IIT and this Descartes' rule of signs. IIT says minimum one real root, Descartes' rule of signs says maximum one real root. So that means if you combine them, you get only one real root between 0 and 1. So that means there is a positive, exactly one positive root in which interval? 0 to 1. So this part is done. Now let us go to case 2. Case 2, let's check whether any root is there x greater than 1 for the polynomial f of x is 0. My polynomial f of x equal to 0, I can write it as x power 2021 plus x power 2020 plus so on plus x square, plus x minus 1. Now when x is greater than 1, x minus 1 is strictly positive. And also when x is greater than 1, all these terms are positive. So this whole thing is a positive quantity. And since x minus 1 is positive, this is also a positive quantity. And sum of two positive quantities is also a positive quantity. So that means this can never be 0 when x is greater than 1. When the function can never be 0 when x is greater than 1, there is no real root. In which interval? 1 to infinity. So this is about case 2. Now, the most interesting part is for the other two intervals. Negative infinity to negative 1 and negative 1 to 0. Unfortunately, Descartes' rule of signs will not help you there, because even if you apply Descartes' rule of signs, the maximum number of negative real roots, it will give you an information as 2020. But how many? That is maximum. And IIT will not give you any information in that, because IIT will never give you the two opposite signs. Just because IIT is not giving two opposite signs, don't think that there is no root. So the converse of IIT need not be true. Okay. So what you can do is, so we'll write my f of x is 0 as x power 2021 plus x power 2020 plus so on x is equal to 1. Because f of x equal to 0, I am transposing 1 to right hand side. So I wrote like this, right? So what we can do now is multiply both sides with 1 minus x. Multiply both sides with 1 minus x. So what we get is 1 minus x into all these terms. I'm sorry, one more thing, add 1 on both sides. Yeah, now you multiply both sides with 1 minus x. So 1 minus x into 1 plus x square plus so on plus x power 2021 is equal to 2 times of 1 minus x. You'll understand the reason why I am doing this. Now if you can remember, this is a standard identity. When you multiply 1 minus x with 1 plus x square till x power 2021, it is 1 minus x power 2022. And right side is what? 2 minus 2x. Or making it as a polynomial, I'll get x power 2022 minus 2x plus 1 is equal to 0. And I'll call this as a g of x. So I am converting f of x equal to 0 to a new polynomial g of x equal to 0. Is this polynomial not looking simpler than f of x equal to 0? Of course, yes. It has just 3 terms. But what is the use is, all the roots of g of x is 0. So I am writing here, all the roots of g of x equal to 0. I mean the set of roots of. So it's better if I write set. The set of roots of g of x is equal to 0 is a superset. Is a superset of the set of roots of f of x is 0. So why it is a superset? If you can observe, g of x satisfies an extra root called 1, because g of 1, when you substitute 1, in g of x, what do you get? 1 power 20, 22 is 1, minus 2, which is minus 1, plus 1 is 0. But 1 is not the root of f of x. So this, because of this extra 1, the set of roots of g of x is 0 is a superset of the set of roots of f of x is 0. That means if I remove this root 1 from g of x, all the roots of g of x are same as the roots of f of x. Okay. Now, since all the roots of g of x except 1 is same as all the roots of f of x is 0, let's check whether there are any negative roots for g of x is 0. Okay. So when x is negative, what is my g of x? X power 20, 22, which is a positive quantity, minus 2x, which is also a positive quantity because x is negative, plus 1 is a positive quantity. So this is positive, this is positive, this is also positive. So totally it is positive. That means g of x doesn't have any negative roots. So when g of x doesn't have any negative roots, f of x also doesn't have any negative roots. That's it. So the final conclusion of this problem is this polynomial f of x equal to 0 has exactly one real root which is positive. So only option 3 is correct. That's it.